So in this brief video, I'm going to show you basically how the clinical eye tracker works. There will be other videos posted on the website in due course, which will take you through in more detail some of the features. But I want to just give you a quick overview of how it works in this video. So the clinical eye tracker software will run on most PCs running Windows 7 or later. It needs to be reasonably powerful. We normally recommend an i5 processor or equivalent, and it needs a USB 3 port to plug the iBar into. It's very simple to set up. You simply plug in the iBar to a USB 3 port. It generally works best on a computer that has two screens. Then you can use one screen to present the stimulus to the patient, and then you've got a control screen where you can see what's going on as the eye movements are recorded. So in this setup, I've got two screens set up. I've got the iBar attached just beneath the second screen, and I'm going to show you how simple it is to do a recording and also to analyze the eye movements. So I have calibrated the system. That's a very straightforward process. The next stage is to select the stimulus that you want to show to the patient. And you do that simply by clicking on Show Stimulus here. You can present text, you can upload your own text and display that in a variety of formats on the screen, or you can display images. You just upload any image you want to the system and it will then display it on the screen. There is a saccade test which will flash on a little dot on the screen alternately on either sides of the screen, and you can adjust the amplitude and timing angle of that. Or there's a pursuit test where a spot is moved sinusoidally across the screen. Again, you can adjust the amplitude and speed and angle. If you want to record eye movements while reading, you can use the rate of reading text, and you can very easily change the background of that text. This is in fact showing the 12 Read Easy colors. So I've set it up to display fairly large text with a white background. So that is now displaying on the second screen. So all I need to do now is to click on record here. So I'm just positioning myself in front of the second screen, and you don't need to keep your head particularly still. It's best you need to keep it within a certain area, and I'm positioned about 50 centimeters or so away from the screen. So I'm going to start reading from the top of the paragraph. So I'm going to simply click on record here, and I'm now reading "Come see the play, look up, is cat not my." Okay, I've stopped recording now, and what you'll see on the screen is the eye movements that have been recorded. So in this top panel, you can see it's the horizontal eye movements, showing the individual fixations on each word. This was reading aloud. You can see that when I started reading silently, I was reading more quickly, and this is the big saccadic eye movement at the end of each row. This is showing the combined data for the right and the left eye. If I click on the button at the top here, I can actually show the information or the eye position for the right and left eyes individually. If I just blow that up a little bit, you can see that actually the eyes were pretty well coordinated. They were looking at the same position on the screen. But if a patient had poor convergence or unstable convergence, that would obviously show up in these recordings. So I'm just going to zoom out on that again. The next trace down is the convergence, and so this is showing the relative position of the right and the left eyes. There's a little bit of phoria or deviation between the eyes emerging, usually during the larger eye movements at the end of each row. And then the bottom trace shows the Y position, or the vertical position of the eyes, and clearly not a lot happens in terms of vertical eye position as you're reading. You've just got a slight downward movement at the end of each row when you go from one row to the next. Then you'll see on the right of the screen we have the XY position, or if you like the scan path, and this is actually showing exactly where I was looking on the screen, and you can see it's automatically saved an image of the target I was looking at during the test. And at the bottom of the screen here it gives a graphic of the actual position of the eyes, the center of the pupil, and the software will automatically work out the horizontal PD and the vertical PD, and from that work out the head tilt, and you've also got the viewing distance. So that's a static display, and as I've shown you briefly, you can zoom in on a particular part of the trace if you wish to. But you can also replay it in real time. So if I just click on the play button up here, you'll see that this little spot is moving across to show where I was looking on the display. Now there's a little bit of noise associated with it. Some of that is recording noise, but actually, of course, even when we try and fixate steadily, the eyes are not completely stationary because of involuntary eye movement. So some of that is just physiological noise. So you'll see the tracker bar is moving across. As that happens, the cursor moves across the traces. You can actually see the image of the eyes here. It gives you the head tilt. I've actually got a bit of a head tilt, about 11 degrees here, which it's picked up. And you can then go back and look at individual parts of the recording frame by frame, like so. I'll just draw your attention to the convergence trace in the middle here. If we just replay it, you'll see it's showing the position of the gaze position of the left and the right eyes, and it's also working out any deviation between the two eyes. So you can see this is the measured phoria in prism diopters, taking into account the viewing distance. And so if a patient has unstable convergence, then that will of course show up in that graphic. So this is a typical pattern of eye movements when reading. Of course, you can use the system to record eye movements while you're looking at a very wide range of stimuli, but reading is obviously one of the useful things that the software can be used for. I'll just show you a recording that I did earlier. This is the software contains a powerful database, so you can record all of your eye movement recordings. This is reading under slightly more controlled conditions, showing the same sort of staircase patterns as you read along each row, and then a saccade at the end of each row. But the software actually goes some way beyond this and will do some automatic analytics on the reading eye movements. And the first thing it does is to model the eye movements, so you can see the orange line that's been fitted to this, which works out exactly when a saccade starts and when a fixation starts. And we can use that information, let's just zoom out again, use that information to do an automated analysis. So if I just clicked on reading metrics, and in this panel here, what we have is a complete breakdown of each of the eye movements and fixations during reading. So if I look at row 2 and click on that, we start with a fixation of duration of 282 milliseconds, and then you've got a saccade of amplitude 1.73 degrees, and then another fixation and saccade, and so it goes on. So you can break it down to individual fixations and saccades. And then the graphic shows the duration of each of the fixations throughout the recording. And on the left here, under fixation duration distribution, it gives the distribution of the frequency distribution of those fixation durations. And the graph underneath here is showing the saccade size, saccade amplitude in degrees. So these large downward bars obviously represent the large leftward eye movements at the end of each row, and these other bars represent the small rightward saccades as I looked from left to right. And every now and then there's what we call a regression, which is a small eye movement from right to left when you go back and reread a word. And then you've got a frequency distribution of the saccade size. And then at the bottom of the page, you've got a summary of exactly what's happening during that recording. So it's worked out that I've read 10 rows in a total of 20 seconds. That's 15 words on each row, so that corresponds to a reading speed of 298 words per minute. And then it also gives you some stats on the fixation and saccade. And you can, of course, print out these reports. So that's a very quick overview of how the clinical eye tracker works. It's very easy to set up, requires minimal calibration, is completely non-invasive, and is easy for the operator to use, and provides a great tool for recording pretty accurately the position of the eyes, and then doing some simple visualization and analytics.